இந்த வீடியோட தமிழ் வெர்ஷன் கமெண்ட்ல பின் பண்ணிருக்கேன். Make use of it. In this session, we will cover two key topics. First, what is MOSFET? And second, the construction of a MOSFET. Let's get started. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. It is a semiconductor device with three terminals, which are gate, drain, and source. Source, this is where the current flows into the MOSFET. It is the terminal from which the current enters the device. Drain, this is where the current flows out of the MOSFET. It's the terminal through which the current leaves the device. Gate, this is the control terminal. By applying a voltage to gate, you can control the current flow between drain and source. The gate is insulated from the current carrying channel by a thin oxide layer. This makes the MOSFET a voltage control device, meaning you can control the current flow between drain and source by applying the voltage at gate. MOSFETs are widely used as switches and amplifiers in circuits because they can handle large current with low power consumption and high efficiency. MOSFET is also called as IGFET, that is insulated gate field effect transistor, because the gate is insulated by an oxide layer. It also has other names. It is often called as MOS transistor. Another name for MOSFET is MOSFET, which stands for Metal Insulator Semiconductor Field Effect Transistor. In 1959, two scientists, Mohammed Atala and Dawan Kang at Bell Labs, invented the MOSFET. They wanted a device that could switch current with little power. By the early 1960s, improvements made MOSFET more stable and manufacturable. MOSFETs let engineers pack more switches on a single chip, and this unleashed the integrated circuit era. ICs, microcontrollers, and memory chips are all enabled by MOS technology. One of the biggest advantages of MOSFET is their compact size. Also, it is easy to use and cheap to produce. These features made them perfect for making electronics smaller, cheaper, and more efficient. The development of MOSFET is often called as MOS revolution. This marked a significant turning point in electronics because MOSFETs made devices smaller, faster, and more energy efficient. And thus it resulted in development of wide range of consumer electronics. By 2018, 13 sextillion MOSFETs had been made. That is 13 followed by 21 zeros of MOSFET. And this shows how important MOSFETs are. They are used in everything from smartphones to computers and automotive systems. Now let's understand how a MOSFET is constructed. MOSFET is composed of several key components that work together to control the flow of electric current. First, substrate. It is the foundation of MOSFET. It is made up of silicon. In a MOSFET, the type of substrate determines whether it is an N-channel or P-channel device. For N-channel MOSFET, the substrate is P-type. This means that the majority charge carriers are holes, that is positive charge carriers. The source and drain are N-type, meaning they can have extra electrons, that is negative charge carriers. For P-channel MOSFET, the substrate is N-type. In this case, the majority charge carriers are electrons. The source and drain are P-type, meaning they have extra holes. So for N-channel MOSFET, the substrate is P-type. For P-channel MOSFETs, the substrate is N-type. Next, source and drain. These are the two terminals where current enters and exits. The current enters through the source and exits through the drain. The source and drain are heavily doped region. We write them as N plus or P plus. Heavily doped region means the source and drain have high concentration of impurity added to the silicon to make them very conductive. Impurities are also called as dopants. So dopants are impurity atoms we add to silicon to make it either N-type or P-type. Therefore, doping is adding extra atoms to silicon to control its conductivity. Heavily doped means a lot of these atoms are added. N plus means it is an N-type region which is rich in electrons. The plus means it is heavily doped, so it has a very high number of electrons. Some common dopants for N-type semiconductors includes phosphorus, arsenic, and antimony. These dopants provide extra electrons to the silicon and are referred to as donor atoms because they donate electrons. P plus means it is a P-type region which are rich in holes. Plus means it is heavily doped. It has high concentration of holes, meaning electrons are missing. Common dopant for P-type semiconductor is boron. It accepts electrons, therefore it creates holes in structure. So it is called as acceptor atom. And thus the source and drain are heavily doped region which are written as N plus or P plus. They are always of opposite type compared to the substrate. For instance, in an N-channel MOSFET, the source and drain are N+, while the substrate is P-type. For P-channel MOSFET, the source and drain are P+, while the substrate is N-type. Next, gate oxide layer. It is a very thin insulating layer that separates gate from the channel region. It is usually made of silicon dioxide. It stops the current flowing into the gate from the channel. Gate electrode is usually made of polysilicon or metal. It is positioned on top of the oxide layer. Next, channel region. It is the area between source and drain under the gate. Here is where the current flows when the device is on. The basic structure of a MOSFET acts like a MOS capacitor. There are two PN junctions formed at source end and drain end. So in this video, we learned what a MOSFET is and how it is constructed. We saw the layers, substrate, source, drain, gate and the oxide. In next video, we will go deeper.